Yes, we have, Keith. We're live. So I guess without any further ado, I'd like to welcome everyone to today's webinar. Today we'll be talking about guidance signs, and I'm very pleased to present Mr. Keith Costle once again. Who, well, if you, what Keith doesn't know about guidance signs probably isn't worth knowing. So in today's webinar, Keith will be explaining the principles from from what they are, why they're there, design characteristics, and then we'll finish up on measurement, in which I will be supporting Keith, and then we'll have a session of questions and answers to address any particular issues or concerns you may have. In doing so, you may have some questions cropping up during the course of the webinar. We won't be taking live questions, but if you can type them into the Q&A box on your Zoom system at the bottom there, we will pick up those questions at the end of the webinar. We're leaving about 20 minutes to go through them with you, and as usual, if they're too many to answer, we will answer them and post the answers to those and all of the questions we answered live on our website. So without any further ado, I'd like to, very pleased to announce Keith Costle, our Director of Training at TMS Training Solutions, who will enlighten you as to the nature, purpose, and measurement of signs. Keith.
Oh, hi. Thank you very much, Robert. I mean, right at the beginning, I think guidance signs. When we look at our guidance signs on an airfield, and I think if you're anything like me, and I get on an aircraft with my wife, and we get our seat, we sit down, and the first thing I'm doing is looking out of the window. And my wife will then say, "Do not mention the lights." And of course, I always do. Why? In our profession, in our world, it's just impossible for us not to look at the lights. And the first lights we tend to see are either taxiway edge lights or guidance signs. And when we're looking at guidance signs, I'm looking to see whether or not I can see the legend of the guidance sign pretty clearly. And I have to say, sadly, in many airports that I've traveled through globally, they're not very good in terms of their luminance and their color, etc. And I have to ask myself why, because these guidance signs have been designed, they've been developed, they've been tested and approved for use on the international sphere of airports. And so when we come to looking at guidance signs, I think that is an area that has been in some ways forgotten and when we're looking at standards, because we tend to think about the runway related lights. We think about those taxiway related lights, whether they're edge lights or taxiway center line or stop bar applications for runway incursion, etc. But do we really pay due consideration to guidance sign? And that's why today I think we have this webinar. Now I have to make an apology on behalf of Mr. Tony Smith. Mr. Tony Smith was going to be with us today as a co-host and as part of the panelists, but unfortunately he's had an eye operation and he's had to go to a last-minute appointment. They offered him at the end of July, but they said, "Oh no, we've got a cancellation. Can you come?" And he said, "When can he come?" "Oh, this afternoon, today." Now, typical, So please accept Tony's apologies, and I'm very sad that he's not here with us, because Tony was the key person in guidance signs and with puppies, because he designed the puppy, but with guidance signs, did all the practical, real on-site aircraft experiments associated with the size of guidance signs, the size of the legends, etc., etc. So, you know, I have to make that apology on behalf of Tony, but when we have our forthcoming webinars, he will be back with us. I also would like to say Damon Creed has joined us today, and he's our IT specialist in many respects. So he keeps us on the straight and narrow in terms of the production of the webinars. So thank you, Damon, and welcome. So,
thank you. Thanks, Keith.
You know, let's move on. Guidance signs. We will discuss elements of design, installation, maintenance, and of course, the way we can now demonstrate operational compliance. And when we look at the design characteristics and when we look at the history behind guidance signs, then there are only two types that are available in the marketplace. There are those which are mandatory signs, red and white looking, and those which are direction signs, which are information signs. And those advisory signs are black and yellow or yellow and black. And that's something that we'll discuss. And but during the extensive research and development associated with guidance signs, then the factors which, of course, Mr. Tony Smith was going to explain is the fact that is the human factor, because we are serving a pilot. It's the pilot, he or she will be looking at those signs when they've got permission to push back at the apron, and then they will transit from the apron to the runway holding position, whichever runway it is, in various visibility conditions, and vice versa. When they leave the runway and enter the taxiway network, they need to be able to transit from the runway back to the parking position, wherever that may be, in the apron, ramp, whatever you want to call it, to enable passengers to get off, cargo to be removed, etc. Or if it's a military aircraft, maybe you know, associated with weapons. So we've got that element because we've got both military and civil operations, and each of those have their specific needs. So when we're looking at the pilot, then going back into the history and the development of the guidance signs, then there was actually simulation trials with real pilots, with real aircraft. And that was to follow designated routes in low visibility conditions. And in those low visibility conditions, of course, you have nighttime and we have the low visibility conditions. And when we're looking at those guidance signs, that's where the colors came into the consideration. That is where the size of the guidance signs themselves came into the consideration. That's when the consideration for the size of the letters on a guidance sign and numbers on a guidance sign, etc. So all these kind of were practical tests, the consideration and then the production, and then those practical tests on with real aircraft and real runway. So when we're looking at a guidance sign, we've got to, obviously it's a light. It has to be illuminated in lower visibility conditions. So in our categorized operations, they need to be illuminated. In a non-category, that is a non-instrument or a non-precision, and where there is not a requirement for night flying, for example, then the size and the shape and the letters, etc., and the numbers all have to be the same, but not necessarily illuminated. But we're talking about illuminated guidance signs. And therefore, what information do they impart to the pilot? So the pilot has to be able to observe, they need to be able to take in that information, analyze it in their brain, and make a decision. And so the time scale associated with being able to do that was based on 10 seconds. So that gives you a bit of an understanding where and how things came about. So whilst a pilot is in an aircraft, the aircraft is not stationary, it's moving. So the next thing was, okay, how long does a pilot need to absorb information and take action? Now, base it around a time frame, 10 seconds. But what about the speed of the aircraft? So the nominal speed for a taxiing aircraft, it was decided to base it on 30 knots. And therefore, then, so that's two factors. 10 seconds to absorb the information, 30 knots speed, because we know if you drive a car on a highway and you go fast, then you have less time to make decisions. So that's where the speed element came in. Then the second thing, well, what distance is it that we've got to be able to look at, and absorb this information, traveling at 30 knots? So 150 meters was decided to be the nominal distance in normal conditions. I'm not talking about a low visibility now. I'm talking in normal conditions, and normal conditions is when we have visibility in excess of 550 meters, which is like a category 1 consideration, but general visibility of up to 800 meters. So in those conditions, it was considered then 150 meters, you need to be able to see the signs. Traveling at 30 knots, and that gives us 10 seconds to absorb the consideration. The next thing was, well, what about the pilot themselves? They're human beings. Well, we think our pilots are human beings, hopefully. So, but human beings are all slightly different. And so the general consideration was, well, if we are slightly different as people, and what about our eyesight? So pilots have to have a particular level and standard of eyesight. And in that particular standard and level of eyesight, then if they need 10 seconds for their brain to absorb the information, traveling at 30 knots, and can see this information at 150 meters in those ideal visibility conditions, then how big do we need to have those letters? And that's where the 40 centimeters came in terms of the letters. So all this was taken into account during those early developments. And I say, Mr. Tony Smith was the man who was involved with all those early experiments. And so sadly, they say, but he will be with us in the future. So if you have any questions for Tony, please put them on the Q&A, as Robert said, and then we can answer them. Or Tony will be available to answer them. Hopefully that we can answer them ourselves. But when you have what I would call the godfather of airfield lighting in many ways, how wonderful it is to be able to talk to the godfather. It really is. And so anyway, so let's move on. Guidance signs. Guidance signs shall be provided. They shall be providing as part of the visual component, as part of surface movement guidance. And as part of surface movement guidance, then it's moving that aircraft from the runway to the apron, or from the apron back to the runway, back to the runway holding position. And when we're looking at those, so that's why we split them into two groups, mandatory and information. Mandatory, red and white, information, as I said, black and yellow, or yellow and black. And we'll look at the differences. We will look at those differences. But then the standards came in. And once again, the standards are defined by what is a working group within ICAO, which is dedicated for visual aids. And it has changed its name over the years. from the visual aids panel to the visual aids working group, etc., etc. But it's a panel made up of specialists from various nations, and then they will look at and assess then the standards. So the standard out of the International Civil Aviation Organization for us for guidance sign is Annex 14, Annex 14 Volume 1, currently at Edition 8. And it's broken up into chapters. Chapter 5 is about the visual aids, and within Chapter 5 it gives details of many things associated with airfield ground lighting, or aeronautical ground lighting is the formal name for it. AGL, we call it simply AGL. And in AGL, then it's the application, the characteristics, the location of where we put our systems, and including the guidance signs. It's also supported, Annex 14 is also supported by a set of aerodrome design manuals. There is a specific one, which is Part 4, which is about visual aids, and there is a specific chapter in there to give us additional information about guidance signs. And then there is the design manual Part 6. Now, this is about frangibility. What do we mean by frangibility? It means that these guidance signs are an elevated line. Because remember, in AGL, we've only got two types of lights: elevated that stick above the ground, and inset or in-pavement lights that we actually embed into the pavement. But these are elevated lights. So these elevated lights are big structures. Now, these big structures are going to be suspect to wind shear in bad conditions, but also jet blast, because the modern aircraft wings hang over the side of taxiways, and they hang over the side of taxiways depending on the model of aircraft. And so they could be directly in line with our guidance signs. And for a jet aircraft to move, in a modern aircraft to move, then you have to rev up the jet engine, basically, and then that blast moves the aircraft forward. Each force has an equal and opposite reaction. So that jet blast going out the back pushes the aircraft forward. And therefore that jet blast could affect our guidance signs. So we need to be they need to be on breakable couplings, frangibility. So the aerodrome design manual Part 6 is associated with that. However, those frangible couplings have to be secured to the ground. And it's the ground that we have to look at next, because in some of then there's the civil engineering side of the aerodrome design manual series. Then it refers to bases, and the bases have to be delineated, that is delethalized. Excuse me. And when we delethalize, that means that should an aircraft leave the pavement for whatever reason and hits our guidance signs, those guidance signs will break and not damage the aircraft. But because leaving the pavement, these aircraft are heavy, their wheels undercarriage may dig into the ground. And therefore, when those wheels dig into the ground and then hit our guidance sign, then the first thing the wheels are going to hit are the bases. So we have to chamfer the bases. So delethalization is a factor that we have to take into due consideration. And that is an area that has not been very well looked at in our industry. Not very well looked at all. But it has become a subject of our times. So think about that. Moving onwards to look at the different types of signs, as I said, mandatory signs, red and white, advisory signs, which are yellow and black or black and yellow. And you'll see from here, I've just extracted out of Annex 14 a diagram which shows all the various different types of mandatory guidance signs. And you'll see here then the legends that are on those guidance signs, you'll see are pretty. If you look at each one of those diagrams on this page of Annex 14, you can see the letters and the numbers are all the same, basically, that size. That's that 40 centimeter concept. The length of guidance signs will be dependent on what we need to put on it. But here, look, you'll see most of those mandatory guidance signs are associated with the runway holding position, with the exception of like a no entry on maybe a rapid exit, So we would perhaps not normally enter a runway with an aircraft on a rapid exit. But remember, on an airfield, we have operations personnel who drive around, including ourselves in AGL, drive around in vehicles. So there's vehicles out in that airfield as well. When it comes to the information signs, you'll see a combination of colors here and a combination of information. Generally speaking, and let's start with the top here, if I'm traveling towards a junction on a taxiway, then I need to know where I am. Well, here, look, it's telling me I'm on Taxiway Bravo as I approach this junction. And this junction ahead tells me it's a T-junction. And then I can go to the left or I can go to the right. But if I go to the left or go to the right, then it's telling me then I'll be turning onto Taxiway Charlie. Now, if I move to another one, say down here, I am traveling along on Taxiway Bravo, coming to a junction, but it's also telling me I can go left or I can go right, but it's also telling me I can go off at an angle. It doesn't tell me what that angle is, but it's also telling me that Taxiway Bravo, which is different to that one, Taxiway Bravo finishes there, but in this case, Taxiway Bravo continues, but it goes on at an angle to the right. It may be it went off to an angle to the left, so it would be to the left. And therefore, you'll see the two types now. The location one is black with yellow lettering. The direction is yellow with black lettering. But the size of the lettering is still the same concept, right? Same concept. We've still got that 40 centimeter. So there's commonality. Now, in some cases, then you'll see something like this. Now, this is a runway vacated sign. Now, interestingly, when there is a single, normally speaking, when there is a single information sign like that, the location sign will be installed on the outboard side, So if I'm coming off the runway, just take these two into account, if I'm coming off the runway and I'm traveling off the runway and onto a taxiway, I'm going to be entering Taxiway Alpha. And that's a runway vacated sign. So I clearly know I'm leaving the runway incursion location and moving onto a taxiway. And I'm being told I'm moving on to Taxiway Alpha. So there's a whole range of information guidance signs associated. But we're not going into the detail of design of the layout and all the different types today. We're talking about really compliance and why we have guidance signs of a particular size and a particular legend of a particular color and a particular illumination, the intensity. So, but on my right hand one here, diagram here, I've just pulled out some typical mandatory signs associated with a runway holding position, because we know from designer element that the minimum distance for a runway holding position, then is going to be from the runway center line 75 meters. But if we go to category 1, that means that the visibility has dropped to, and when we talk about visibility, we're talking now about runway visual range visibility. And what is the difference between the two? Then general visibility is how far can I see across the airfield, that kind of thing. RVR visibility, runway visual range, is when the pilot is sat on the aircraft, on the ground, on the runway. How far can he or she see the visual aids down the runway? That's RVR. We've got equipment that tells us that. And so when the RVR visibility drops to 550 meters, then we then go into what we call the category 2 conditions. So prior to that, when the visibility is above 550 meters RVR visibility, it's category 1. Then we get category 2, and then we get category 3. So category 1, down to 550 meters RVR. Category 2, down from 550 meters to 300 meters RVR visibility, and below 300 meters RVR visibility, it's category 3. And there are 3 levels of category 3. So we move, for safety reasons, our runway holding position further away from the runway center line. So we got more clearance in those lower visibility conditions. And therefore, we identify those locations. The distance we move from a 75 meter minimum distance for Cat 1 is 90 meters. And for Cat 2 and 3, it's a minimum of 107.5 meters. But in some cases, for category 3, we move to 120 meters. But that will be dependent on airfield layout and operational requirements, etc. So there's that's an application of the mandatory guidance signs, which have been, as I say, designed and developed by that criteria we've already discussed. So moving on, we've got to illuminate them. Now, we illuminate them in different ways. Now, the modern way is an LED, but we have traditionally used fluorescent tubes and halogen tubes. Now, halogen lamps. Now, when we're looking at a tungsten halogen lamp, its life expectancy is somewhere in the region of 1,500 to 3,000 hours at 6.6 amps from a traditional 6.6 amp circuit. And therefore, these halogen lamps, nominally, we've used a 48 watt, well, we call it 45 watt, but a 48 watt lamps in there. But 1,500 to 3,000 hours, it's not very long, is it? Not very long at all. So, you know, from a maintenance and a planned maintenance viewpoint, we really have to think about guidance signs. And have we thought about guidance signs too much? I mentioned right at the beginning, actually, we've not paid too much attention to them. And so what we get is a bright light in the middle of the guidance sign and darkness around the edges. Fluorescents, however, were a better illumination in terms of the spread. But the only thing is with fluorescents, now fluorescents, whilst the life expectancy of a fluorescent tube is around 10,000 hours, obviously from a practical viewpoint and from a maintenance viewpoint or longevity viewpoint, much better. But once again, fluorescents deteriorate and you get that fine line. You get the darkness around the edge. So LEDs have come in LED strips. Now, depending on the LED strip itself, the length of it, then the consumption of it is going to be, I say, depending on the LEDs themselves. But when we're looking at an LED, the life expectancy is around 50,000 plus hours. So clearly, the longevity helps us. But they also, when we're looking at LEDs, when we're looking at the LED as a light output, it is a DC component. It is not an AC component. And when we're looking at that as a DC component, then of course we have to have more electronics in there to be able to convert. If we're going to connect it to a CCR, which is an AC output, that's another subject, whether we use thyristor-based CCRs or IGBT transistor-based CCRs. That's also another factor that comes into the equation. But 50,000 plus hours is probably a good, but the LED to the human being, to that pilot, our end user, because that's what we're talking about, then they seem to be much clearer, much crisper in terms of color and intensity. They're not as such, if you measure it with a calibrated tool, they are the same as the other lighting sources, but it's better for us. And the spread, because we can put them in strips, the spread can be better. So LEDs have brought some positive advantages when it comes to guidance signs. Here is a typical designer's layout of a runway holding position of the various types of guidance signs that we can have, which is a mixture of mandatory at a runway holding position, an advisory, knowing where we are and which direction we're going to go. There's also the difference here. We show the difference between military and civil, because the basic difference, I'm not saying this is exclusive, but the basic difference in visual aids between a civil and a military airport is, in a military airport, we would have distance to go markers, distance to go. How far is it before we fall off the end of the runway? That's basically what it's telling us. So there is the fundamental difference. So this is a typical layout. Where do we put those guidance signs according to the size of the taxiway, side of the taxiway or the runway? Well, we have a chart in Annex 14 which tells us that. So in that chart, then you can see, look here, that this chart actually has been around a long time, from those early days of designing and where guidance signs and where we should put them. Because when we look at, then it says perpendicular distance from the defined taxiway pavement edge to the near side of the line. Perpendicular. That means it's at right angles to the center line of the taxiway. Now, if they're at right angles to the center line of the taxiway, then surely in the modern jet aircraft, if those jet engines are hung off the bottom of the wings directly in line with the guidance sign, then blasting air perpendicular to the fascia surely would create more potential damage. So there has been a lot of discussions in the industry associated with sizes of guidance signs and whether or not they should be angled. That is not perpendicular. So I have to say these discussions are ongoing. That's all I can say about that at this time. But the standard says perpendicular to. And there is a difference between those distances depending upon the category, the code, sorry, not category, the code of the runway. So if we're code 4, 3 or 4, you see those guidance signs are going to be, and we give them flexibility on that perpendicular distance between 11 and 21 meters. So we can take due consideration of some aircraft. But what if we get other aircraft? We get multiple sizes of aircraft. So once we've fixed the location of the guidance sign, that's where it stays. We can't have it on a sliding scale depending on the aircraft type. So this is where these discussions of sizes in terms of lengths and in terms of whether they should be angled so that some of the jet blast can be deflected and not potentially damaged, but be a less potential damage to the guidance sign. On the side of the runway, there are again some different figures. Category 3, 4, 8 to 15 meters, whereas on the taxiway itself, 11 to 21 meters. So there's the criteria as currently available in Annex 14. The other aspect is a typical, I've shown a typical example here, look, of an elevated guidance sign. And that elevated guidance sign with its legends are on frangible couplings. Those frangible couplings are bolted into a structure, a base unit, a concrete structure that is buried in the ground. Now, we have to take due consideration that this is just a diagram which can show both the physical element, but where we can put the electrical equipment in terms of the isolating transformer adjacent to the guidance sign. But when we take due consideration of this base unit, look here. Please take note of other ICAO guidance about delethalization of the base unit itself. We've already, take due consideration that has to be chamfered. And that chamfer guidance is given to us. We also have to consider that frangibility in terms of when we're designing a guidance sign, whether we are in the ICAO world or whether in the FAA world, there are some minor differences, but we base that on speeds, etc., in terms of kilometers an hour, meters per second, or knots. So here we are, we're talking about knots. So there's some of the criteria associated with wind and jet blast. That means that the sign shall be stable, it shall not break away from its mountings, and it should be capable of being exposed to both wind and jet blast, as I mentioned, without distortion. So without breaking, I think that's quite obvious, but without distortion. And one of the things we really need to take into consideration is that how do we mount that guidance sign to that concrete base? That is the structure. We're mounting the guidance sign on a frangible coupling. That frangible coupling has to be bolted securely to that base unit. Very important. So there are these yield levels that are taken into consideration in frangibility. Aerodrome Design Manual, Part 6. When we're looking at, say, I've given one or two little drawings here, and these are advisory signs. This is a location, there's a direction sign, and it's going to sit on a coupling that is bolted to the ground. So that as a weak point built into these frangible couplings, and that weak point has to be at a particular maximum height above the base unit itself. So these criteria are all built into the design, not just of the guidance sign, but on the size of the guidance sign and the type of frangible coupling that we can select to use. So just really a bit of an awareness and a bit of an introduction to the criteria that I have to say Mr. Tony Smith actually went through in terms of the calculations and then the practical application of testing. I've mentioned size already. If you want to put a lot of information, obviously it's going to be quite a big sign. But when we looked at the design of the signs themselves, it wasn't just only the size of the letters and the numbers, that 40 centimeter concept that I spoke about, how far the letters should be from the top, how far they should be from the bottom of the guidance sign, how far they should be from the side of the guidance sign. And therefore, if you want to put a lot of information, there's no way that you could bolt a lot of little guidance signs together to give that information, because the letter number spacing would be wrong. So these criteria have all been discussed, all been trialed, but at this moment in time, the guidance is that the maximum size shall not exceed 3 meters in length. Hence, where if you've got something at 3 meters in length of a particular size like that, then clearly that's going to be potentially subject to wind shear and jet blast. Hence that consideration about no longer installing them perpendicular, maybe we should be angling them to deflect some of that wind shear or deflect some of that jet blast. But the jury is out on that subject at this moment of time, let me say. The jury is out. Delethalization, I've mentioned that before about the base unit. Now, the base unit, dependent upon the sign itself, will need to be of a specific depth, and therefore on the edge it needs to have a chamfer should an aircraft come off and hit the guidance sign, so that if it hits the guidance sign, the wheels will have dug into the ground because of the weight, etc. of the aircraft, the mass of the aircraft, and therefore we want it to be not to damage. The base unit will also not damage. So whilst we have a guidance sign that is frangible on its coupling, the base also has to take due consideration. And so I think this really speaks for itself. If you need any questions about delethalization, please call us and or raise them on the Q&A, because I see there's quite a lot of questions coming in on the Q&A, which we'll be able to hopefully answer, and or we will of course publish this afterwards. Color, red, yellow. Black is not a color. Anything is black is not deemed to be a color. So basically we have red, we have yellow, and we have white. And when we're looking at AGL and we look at chromaticity, we base all our criteria associated with white light. And then there is a deterioration factor according to color. And that was based upon having a white light source. And when you got color, you had to filter it to get the color. With LEDs, of course, things have changed quite a lot. And so when we're looking at LEDs, then has that changed in terms of the guidance signs? No. We have a white LED, but we still get our colors by having the fascia. So there's a little different between our standard AGL lighting in terms of runway related lighting, you know, center line or runway edge, etc. Then the LEDs are either red LED or a yellow LED or a green LED, etc. Not so with the guidance sign, it's still a white light filtered to get the color. So we've got to make sure that filter ratio is good. So we have these ratios associated with the colors. So you'll see here, look, if I've got a 300 candela per meter squared white light, then if I wanted to go through a yellow filter, that is the fascia's yellow, then there is a 50% reduction of that light. And if we go to red, then there is a reduction again associated with it. We also have to take the consideration about those RVR conditions and that 800 meters visibility I spoke about. Then the overall visibility is either above or below 800 meters visibility. Don't get visibility mixed up with RVR visibility. RVR is runway. When we're talking about taxiways, we're talking general visibility. So we're talking 800 meters and then above or below. So that's the criteria. So we define exactly what the candela per meter squared on the guidance sign is going to be, depending on whether we're above or below 800 meters. So that's what that is giving us there. How do we measure luminance, the average luminance? We have a grid system. And I think all of us will be familiar with the grid system associated with isocandela diagrams. And so guidance sign has its own isocandela requirement, and it has a grid system, but there is specific places on that grid system, specific places on that fascia that we measure the luminance, and we add them all together in an arithmetic way and divide by the number of points as shown in that grid system. And it is defined in the aerodrome design manual part 4 how we do that. So very, that's the average luminance across the screen. We've also got a uniformity consideration. We've also got this, we need also to have uniformity between these points. No point in having the brightness in the middle and darkness around the edge. We have to have uniformity. And when we have, without going into the detail, I'm not going to go into the fine detail of uniformity of white light, uniformity of red light, yellow, etc. But that all to bring to your attention, there is uniformity in the isocandela that we have to check. And that's what we're really checking when we're checking. I want to demonstrate and justify compliance, because as I said, no point in having a bright light in the center and dark around the edges. There's no point when we're thinking for 10 seconds, a pilot, 10 seconds at 150 meters, traveling at 30 kilometers an hour, 30 knots, sorry, not 30 kilometers, 30 knots, then can I see it? There's no point in them being able to say, what does it say? So we need to have this uniformity associated. The chromaticity, I think all of us will be familiar with chromaticity, the color criteria as defined, and there's some clear defined areas associated with reds and yellows and whites that we have to. So we need to make sure that our color ratios are within these sectors. And that's what we can test in today's day and age. We're going to check whether we are within these sectors. If we do not clean the fascia, for example, then it looks dirty, we're going to deteriorate both light output and the color perception. So my questions to you, or our questions to you, is on your airport, can you realistically demonstrate or justify that the photometric coverage across that your guidance sign conform to the standards? And does your specific guidance signs on your airport have dark edges? Because my wife sitting along me in an aircraft, she can say, what are you looking at? I said, oh. She said, I've told you not to look at the lights. I said, I can't help it. And she looks out as well. Well, what are you looking at? Show me. I said, well, she said, well, that's not very good, is it? So it's a bit bright in the middle, but I can't see the edges. It's not rocket science to work that out, is it? My wife can do that. I hope she's not listening. But, so even she can tell that some guidance signs are non-compliant. So how can we cost? How can we demonstrate and justify? Well, we can. We have got today a sign tester that can do that for you. And what I'm going to do now is introduce Robert. Again, Robert, you're with us.
Hello, Keith.
You can tell us all about this sign tester, which is also can do puppies as well. So I understand.
Yes. Yes. So if you've now I hope you're I'm very pleased to see everyone's still with us. We've got there's so much in this, and we try to give you as much information as possible in the time, but I can see we're going to run short again. Yeah, as I think Keith might have mentioned once or twice in previous webinars, but for the first time today, you can't manage what you don't measure. It's all very well going out on a fine day and looking at signs or pappies indeed, but signs we're talking about here, and saying they all look very fine. But it's in low visibility conditions that you need to consider, are they capable of doing their job? Because that's when compliance comes to the fore. It's important at all times, mind you, but in particular in low visibility conditions, because you may not even see the sign if it's not functioning according to the required specifications, as Keith has been explaining to you today. So in response to our customers, they've asked us to develop a device to measure the intensity of the background of the sign, to test it for compliance with the requirements of ICAO, FAA, and national regulations, as Keith has been outlining, and also to measure the characters, the sign characters, for compliance, to ensure they're conveying the information as required. And so we have a simple device that can be placed in front of any sign that will rapidly measure it for compliance. If you could go to the next slide, please, Keith.
Mm-hmm. Let me just move it along.
So this is an image of the device. It's a tripod-based device. Here in this picture, it's actually configured for the for PAPI measurement. You don't need the photometric arm for the sign measurement. That's only needed for the PAPI measurement. The camera measures the luminance of the sign. It's a process that would take about 3 minutes per sign, and even quicker if you don't want to see the results instantly. It measures, as I say, the luminance and the intensity ratios according to the methodology that Keith has outlined and specified in ICAO, FAA, and other standards. And it also measures the sign characters for compliance. Next one, please, Keith.
Mm-hmm. Oh, sorry. Let me. Right. I have to. Here we are.
Indeed, So here we've got an example of one of the reports there, and if you can just make out there, we measure each of the grid points in the sign, and we write, and it's stated there, and then we compare the ratios. So for the adjacent points, so each point should be no more than 1.5 times any adjacent point in any direction. And overall, there should be no more, ratio should not exceed 5 to 1 from the brightest point in the sign to the darkest point in the sign. Um, Now, it's very interesting when we actually go out and test signs. We provide the equipment for customers to do it themselves, but we also provide it as a service. Um, Particularly we're doing a lot of work on new installations, and it's surprising how many new signs and also signs that have been converted from other light sources to LED um, are non-compliant. They're often much better, but the point is that they're not meeting the standard. You have to have a measurement. You would expect that if you're paying for an upgrade or buying a new sign, it would be compliant. Um, but so I would thoroughly recommend. It's a very worthwhile investment to actually test new signs when they're installed. It should be, if you're a designer out there, please specify it in the project requirements, because otherwise the airport may end up being stuck with signs that are non-compliant, and there's nothing they can do about after the warranty period or whatever has expired. Um, so it's very simple. It's very simple principle. Coming back to the point I made earlier, you can't manage what you don't measure. To all sign manufacturers out there, I would urge them to actually manufacture the signs that exceed the requirements of the standards. Even when they do pass, they're very marginal. There's not a lot of margin for error in the manufacturing that we have seen. But certainly when you have new lights and signs installed, do get them measured to ensure they're compliant, and indeed they should remain compliant throughout the warranty period. So perhaps you wait until later, but obviously you don't want to do it once warranty has been invalidated for any reason, which could include performing routine maintenance. For example, in the case of an AGL, replacing a lens. Next one, please, Keith. This is an example of a summary sign test report. In this case, the signs actually failed. If you can see there, what we record there is the mean average lux on the sign fascia. In this case, it's a yellow sign. The standard is 150 candela, and it's only 146.3. So it's a fail for that reason. The adjacent ratio has also failed. The requirement, as Keith specified, is no measurement should exceed the adjacent one by more than 1.5 times, and in this case it's 1.54. It's marginal, but it's still a fail. This is not discretionary. And then overall, the sign, it's actually very good in terms of overall uniformity. This sign, the overall ratio, the brightest to the darkest point is 1.95, which against a standard of 5 times is a very good result. So it's probably a very good looking sign, but unfortunately it does not meet the standard. We don't set these standards, and most importantly, they're actually there not for general conditions when you're driving around an airport in good visibility. They're actually there for low visibility conditions, and that's where these factors of uniformity and the background luminance come into play. So to make the sign conspicuous, which is what it's there for. We also measure the color there, so you can see the XY coordinates of the yellow, and that actually is compliant as well. And the face character is yellow, as you can see, from the standard of 150, and it's failed because it's only 87.4. So the actual face character is quite poor in terms of luminance. Next, please, Keith. Right, so here again we have another image that we produce for. This is a different sign here. In this particular case, the sign has passed 213 candela compared to the standard of 150. the ratios are all okay. So this is what we like to see. I really do like. I we don't want to be negative. It's much easier for us, and it's much better for you that your signs pass. But unfortunately, if they don't, you need to know about it, and you need to plan what to do about it. But in this case, you can see the overall illuminance is a pass by 142%, and the individual the individual adjacent measurements ratio is 1.49, just within the allowance of 1.5, and the global ratio of 2 compared to 5 is a very good result. So that's a good sign, a good example. Next one, please, Keith. Right. So if you do need any help with your signs, we've got to achieve conspicuity, legibility, comprehensibility, and credibility, so that the users of these signs, the pilots, can get the visual cues they need to take off and land safely in the conditions that they are allowed to, which of course includes low visibility. Please let us know. We'd be delighted to help you. We're going to go on to questions and answers now, but there is, we do provide, I would point out, we do actually provide comprehensive training courses on all aspects of visual aids, AGL and ground traffic management through our TMS Training Solutions company. Look at the website for more details. It's there on this presentation, which will be posted on our website following this webinar. We're happy to answer. Keith is always happy to answer your questions, but on a case by case basis. But if you do actually need training to have a better understanding, a better in-depth understanding of the purpose, the design, how to design your signage, how to manage your signage, maintain it, and how to demonstrate compliance, then I think a training course is probably relevant to you. But for now, let's just go to. I can see a number of questions here. Keith, are you ready?
Yes, certainly.
We'll go for 20 minutes, but as my experience is that we generally get more questions as we're going through. So Rajendra has asked us, the ICAO design manual part 6 does not specify a breakpoint for a sign at wind velocity of 480 kilometers per hour. This is important for aerodromes like Dubai, where there's significant A380 operations, where jet blast plus wing vortices generate similar wind velocities. Only FAA provides guidance in this area. Do you know if ICAO is planning to include any guidance in this, similar to the FAA guidance?
I think here I can answer that. So, right during my part of the presentation, I said, the jury is out. Right, the jury is out, and there are quite a few things under discussion at this time, including the aspect and the effects of, say, for the American military C5As, for example, the A380s, where what are those jet blast loadings? What are the location of where the guidance signs have been installed? Because remember, most facilities on an airport have been around for quite some time. And therefore, when we're looking at the location of that tolerance of where guidance signs have been installed, then have due consideration being given to the location from the taxiway edge, for example, then for the newer generation of aircraft? And I would say potentially no. This is why I said guidance signs right at the beginning have kind of been left a little bit behind in that respect. And in that respect, then ICAO's guidance is somewhat left behind. So the jury is out on quite a lot of these elements associated with. So whether they are actively discussing it as we speak, I cannot answer that. But what we can do is to talk to the chairman of that visual aids special working group, and the chairman at this time is Mr. Andrew Badham from the UK CAA. So we can actually get that question answered directly from him, can't we, Robert?
Absolutely. Keith, in particular, I've noted through the COVID period and doing a lot of testing myself, I've seen quite a few signs damaged by aircraft that are large, that have somewhat larger, particularly cargo aircraft being used at airports that wouldn't normally have those large aircraft. So certainly it's a consideration, probably a bit late now to point out that, be very careful when you're getting additional traffic, what it is and what the cost of that might be. But in particular, one question that's been raised is the signs are required to be installed perpendicular to the runways, to the runways and taxiways. Some airports have taken the initiative of putting them at a slight angle, or angling them to mitigate the impact of direct jet blasts. Now, this is not in compliance with the requirements. What should airports do that? Can they have it? Can they? One of the airports I'm at the moment has actually been written up for doing this. It's a new installation, but they've actually taken initiative here to actually mitigate a problem.
Well, you want a personal view, or do you want the formal view? From a personal view, I think I think it's an excellent initiative. Now, if we think about the aspect I've said about wind shear and jet blast, then if you can deflect an element of that wind shear and jet blast away from that fascia, then clearly the potential for damage is going to be lessened. Now, if we took the concept of how the FAA give guidance for runway guard lights, for example, a runway guard light is quite small. It's not going to be generally affected by wind shear, but it's about visibility. And when you look at the visibility, if we look at FAA guidance for visibility of a runway guard light, they say they are angled so that they can, ICAO say they are angled so they can be seen by the pilot of an oncoming aircraft and the driver of an oncoming vehicle, but they don't say what the angle is, etc. But what the FAA do, and I think it would be a sensible thing for guidance signs, would be to look at the distance, where is the driver of a vehicle, or let's say the primary need, the pilot of an aircraft, they are on the center line. And so at a particular distance, now bear in mind, we've discussed 150 meters, in terms of the design of guidance signs. Well, if we took an angle and then took that line from left and right and take it back to where those two lines would, a line perpendicular to the fascia, cross the center line of the taxiway, then we could determine what that angle is.
Right.
And see whether how much of that wind shear and jet blast could be deflected.
Right.
So I think that initiative is an excellent initiative.
Good.
However, maybe we should discuss with Mr. Andrew Badham, who's the chairman of the working group, or visual aids panel, whatever we call them nowadays, and whether or not it is under discussion.
I think that would be a good idea. So now do some quick fire answers, because I've got otherwise the questions will run away with us. Cathy Velu would like to know how far guidance signs should be placed away from the runway center line as the runway width varies. Where can he find that information? Can you just point it out?
No, it's not. It's not about where the guidance sign, according to the center line of the runway. It's from the table I showed in our thing is from the runway edge. So the dimension is from the runway edge, not from the runway center line, and that takes that obviously question into due consideration.
Okay. How important are the guidance signs for surface movement guidance control system procedure designed to avoid runway incursion of an aircraft and vehicles on an active runway, take into account other elements of Annex 14?
Let me see. How important are the guidance signs or procedures designed to an identification of the aircraft? Well, I think they're guidance signs. What is the name? Guidance signs. It's telling the pilot of an aircraft or the driver of a vehicle that if they're the red and white ones, which is the mandatory, look, this you take due consideration. This is mandatory information. And if they are direction signs, which information signs are telling the for example, an information sign associated with approaching an active runway would be distance to go, how far you've got before, to take off, that kind of thing. So it is so important. It is part of a surface movement guidance process. We talk about surface movement guidance and advanced surface movement guidance using taxiway centerline lights, stop bars for runway incursion protection, lead-on lights, etc.
Right.
Equally important is the information, mandatory or otherwise. So yes, they are important. So if they are just as important, then they should be compliant.
Exactly.
As simple as that, especially in those lower visibility conditions.
Then we've got I think we've covered the sign requirements for different visibility conditions. If there's any more questions on that, please get back to us. Gaurav would like to know if there are two runway exits, two runway exits, a distance of less than 100 meters. How do you what kind of runway exit signs do you provide?
I think we need to look at the detail to be able to answer that correctly, of the layout.
That's a very specific question. We'll take it offline.
Okay, so Gaurav will get back to you directly on that. Right. I know you're in India, so we'll get back to you, mate.
Okay. Our good friend Bart would like to know: Bart Marischal would like to know: do guidance signs need to be installed level, or can they follow the shoulder or turfing slope?
Do you know, that's a very good question, and it's come up several times. And we're talking about the mounting, aren't we? We're talking about the base unit. We're talking about delethalization of the base unit. We're talking about the height of where the frangible part should be. So the reality is then in practical terms, we try to make them straight and level. So the bases are put in straight and level and delethalized.
Right. Do we know? I know that symbol design is mentioned in Annex 14, but is there a standard symbol font for sign design?
I don't quite understand whereabouts.
We've had this question. As I recall, a similar question. The actual font for the sign characters is a unique one, I believe, and I think there is something available now to actually recreate it.
It's taken from the Greek. Originally, I think the font was selected from the, you know, it's from a Greek designation.
Keith, we've had. I know.
Yeah, we've had this before.
We will just check the answer. It's not a straightforward answer, and we'll post the information on our website so you can see exactly what font it is. There is a. It was kind of a unique one, but it is now available, I believe.
It is, and I'll liaise with Tony on that one because he has an extensive history of why such a font was chosen.
Right.
Yes.
Will there be derogations on the current designs concerning legalization of sign bases? When will it be mandatory for designs, or is it a current standard now?
It's a current standard now. It's in it's in the civil side of the aerodrome design manual series. Because remember that the design manual series that we look at is part 6 for frangibility and part 4, but there is parts 1, 2, 3, and 5. In those design manuals 1, 2, and 3, there is specific. That's on the civil side. It's mandatory now. It's not been looked at too closely in the past, and I know when regulatory bodies, regulatory inspectors from a civil engineering background, because not all inspectors are from a civil engineering background. We have a range of our engineering personnel, but when they're on a civil engineering background, there is a specific attention nowadays made to delethalization, and it's in the aerodrome and the civil aerodrome design manual. Right. Mandatory.
Okay. Gaurav wants to know, can we check sign chromaticity of mandatory signs with the tester? The answer is yes. We can check. We check the chromaticity of the red, the white, and the yellow with our tester, and it's shown on the face of the report with a pass or fail. Anonymous questioner has asked us: do you know of any sign design software being available?
Yes, there are some available. I've seen them posted on LinkedIn, and so the answer to that question is yes. If you need to get that information, of course, the software, of course, would be a proprietary software, but the answer is yes.
Should the back of signs does it need to be marked like a fixed object?
Good question. Very good question. There's something I think that's come up in EASA in Europe. I think the EASA ADR, the aerodrome regulations, then refer to that. I would need to relook at the latest, because the latest guidance from EASA on the whole range of AGL has just been reissued. So I would need to check in the latest ADR whether or not it's still mandated. But of course, remember, when you're looking at standards, you have the International Civil Aviation Organization standards in terms of the annexes, supported with the aerodrome design manuals. And then if you're looking at those national deviations or regional deviations, one could call the FAA a regional deviation. One can call the EASA in Europe a regional deviation. And what they are additions to the basic standard. They are not differences, they are additions to. And therefore, in many designers, we look at, for example, where there is something missing out of the ICAO documentation, because an ICAO documentation tends to be a performance-based requirement, but not how to do it. When we sometimes need to look at the detail, for example, those runway guard lights, like I mentioned earlier, then it is only really the FAA that pioneered and said, well, these are the angles you actually do them at. So if you're looking at detail, which you cannot find in ICAO, consider your regional or your national deviations, because it may be covered.
Right. Thank you, Keith. Ali would like to know, referring to the Aerodrome Design Manual Part 6.4.9.5, which I know you have beside your bed. The overall sign mass should be limited to 24.5 kilograms. Is this a standard and mandatory, or is it an ICAO recommendation?
Well, an aerodrome design manual is a design manual which it will say in a design manual, it shall or it should. And when it's a should, then of course it's a recommendation, wherever practicable. When it's a shall, then becomes mandatory. But normally the shalls will come in the annexes, because it's the annex which is mandatory. The others are guidance documents.
Right. So this is a should, but it's a strong recommendation, but it's not a shall, obviously. Right then. Moving on. What is I think you answered this in the presentation, the minimum distance from the runway. We're talking about the runway edge. That was already covered, I think. What is mandatory change to the fascia when the color fade out? Is it mandatory? Yes. If your fascia, we're seeing this a lot, in particularly, you know, in climates with a lot of sun, a lot of direct sunlight, but also where there's a lot of jet blast or damage from, let's say, sandstorms and the like. The colors, the signs fade, the fascias fade tremendously. This is not an acceptable excuse for non-compliance. You have to replace them. And in particular, I would point out that we've been testing some of these where they're doing where they're doing an LED upgrade and not changing the fascia, and they're non-compliant when they've been upgraded. Well, what do you expect if the fascia has been there for 20 years in a very hot climate with a lot of in this case sand and jet blast? The colors will, the sign fascia fades. It is no longer transparent, and it needs to be. It is absolutely mandatory that the sign is compliant. So yes, they need to be changed.
I think on that one, Robert, is to come back, is that the interesting thing for airports to really understand is that what will happen when there is an accident or an incident. And we come back to the statement we made during our other webinar series. Whatever decision you make, be confident that you can make clear in a court of law when you're answering in a legal investigation following an incident or accident, when they say, was your guidance sign compliant? You say yes or a no, because depending on what you say, yes or no, they will search down. You have to be sure you can be honest and being able to answer in a coroner's court when there are deaths involved.
Yes, and in particular, I see here, Satir asks, what's the recommended frequency of photometric tests on signs? Well, the answer is that there's a requirement for an airport to provide signage that is compliant. So when you and there's no regulation if you that says you must do it any particular interval, because it won't protect you if the sign is found to be a contributory factor in an accident. Um, but but it was a contributory factor, but it was found to be non-compliant. So the frequency of testing, as with all visual aids, will depend on the prevailing conditions um, at the airport. You do what is necessary to maintain compliance.
Correct.
Keith, yeah. Um, we also Sonny also was asked about the font, which I think we've answered, and to say, is it what what? And I think he has a sign here which is 3.1 meters. We said that the maximum is 3 meters. What if you're an airport with a 3.1 meter sign, or great, or anything over 3 meters? Um, I guess you have to do something about it, or have it agree with your regulator as an exception to policy, and that will be fixed next time it's replaced. Would you say?
Well, standards are standards, and at the end of the day, it's your regulator that will give you the license to operate.
Yeah.
And so the regulator will make a decision. Yes, there are always deviations from the standards for practical purposes, but then then normally speaking, then we have to go through a safety case, that kind of concept. We do an safety analysis whether or not it's going to affect operations in all visibility conditions for all aircraft that are using the airfield, and that has to be presented to the regulator. So if you are outside the standards, then you need to present to do that.
I've just a question here, anonymous question. Is there any standard that needs to be followed regarding the alphabet number and direction sequence? It means starting from left to right direction, placement of number, letters, and direction of sign, etc.
Well, yeah, in the design of a sign itself, then the legends, how far they are from the edge of the physical edge of the sign, the fascia, etc. All that is in the either Annex 14 or in the Aerodrome Design Manual Part 4. So I think that should be sufficient to answer that question.
Rajendra has asked, for multiple taxiways that branch out from a vertical, is it permissible to angle the arrows on a guidance sign to
No.
align? No.
No. There is no differing angle in a guidance sign. It's just advising the pilot, then it is an angle, but doesn't tell you the degree of angle. So the answer to that is no.
Right. As a question here, I don't know if you know this one. It says, has newly proposed sign size by ICAO of 600 millimeters and 400 millimeters instead of 800 and 600 been implemented or not?
Well, that I'm not sure. I would have to check that. I'm being honest and say on that particular question, has newly proposed size of the sign by the 600 by 400 instead of the 800 by 600 been implemented or not. I would have to double check that.
Okay, I know that in our measurements we've come across 400, 600, and 800. So
yes,
they're all standard to me.
Mm.
Right. Next question concerning the letter M. What is the width of M, small not capital? Is it anywhere in ICAO?
Yeah, well, yes. I would have to double check that smaller because the M's normally is in capital. So when you're looking at the legend, then we would have to look at that.
And your last question, IHP signs for a surface movement guidance system is a requirement or recommendation only?
I'll answer that offline.
Okay. Well, thank you very much, Keith. A enormously informative webinar. I thank everyone for joining us today. I think you certainly got value for money on today's presentation. If you'd like to know more about signs, of course, Keith would be delighted to welcome you to a TMS Train Solutions sign training session. And if you have any more questions, please just drop them to us, and we'll do our best to answer them. We'll post all the answers on our website, along with the webinar details. And I think, Keith, just to wrap up, I was thinking for the next webinar, I've been asked to do something on understanding photometric test results. The questions asked is, are the visual aids of an airport compliant? That is, giving the visual cues to the pilots they need to take off and land. How do you know? Obviously you need to measure, but how often do you need to measure? How do you measure? And what do the results actually mean? So I've been talking for some time to our colleagues out there, and I said we'll do a kind of a case study workshop, just running through the points to answer this question with some real examples, helping people understand and interpret photometric measurements. And
I think it's a very important subject, Robert, because I see tools out there doing photometric measurements. And then when you do a photometric measurement, it is a calibrated tool. And any calibrated tool, whether it's a mega, or a multimeter of some description, or any measurement tool, a torque wrench, etc., then you are capturing data, you are analyzing the data, and you are presenting the data. And it's the capturing of the data. If it is not accurate, repeatable, etc., then what do you do with that data? Do you change your analysis method to average it out? And what I do see is the data capture equipment. I see a lot of vibrations going on in some models of photometric testing, mobile photometric testing, and that gives me a lot of concern. Really. So I have to say that the observations I personally have made then over the years, I am very comfortable the fact that you in your organization have decided to have a common platform for housing those data capture equipment. So we remove that element, because I've seen them on the back of the vehicle, on the front of the vehicle, in different, and I just wonder about the accuracy, to be quite honest, in some of them. And so I think it's a very, very good subject, and we'll cover it under data capture, data analysis, and data presentation. Good. And excellent. And that leads us on, of course. Yeah. We've got to also, Robert, is when everybody's starting to there's a few people have left us, but for those of you, please complete the survey that is going at the end of this presentation, because the survey will give you the free invite to the next one. And the next one is about planned and predictive maintenance. Planned maintenance in ICAO is called, has its particular name, and I like to call it targeted maintenance personally. But of course, when you are doing planned and preventive maintenance, differential maintenance, which ICAO call it, then if you can record that information in real time with an effective asset management system, then of course it leads us to predictive maintenance. We can predict when to do our maintenance. And that is the subject of our next webinar on Tuesday, the 28th of June. Same time, 1400 to 1500 plus, we will say, because we always run over. We always
Thank
run
you.
over.
Thank you.
And
Thank you, Keith.
It's
Thank you,
lovely to
Keith.
have
Yeah.
everybody with us.
Yeah, and thank you, Damon and Felicity, for all the hard work in putting this together.
Yes.
Tony, we wish you all well, and I hope you're back with us for the next webinar. And of course, most important, thank you for all of you for being our audience and your interest in our webinars. We much appreciate it. Thank you very much, and complete the webinars.
Stay safe.
Survey. Thank you. Goodbye.